Okay, so let's start. I hope you can hear me well. My name is Daniel. I'm the Technical Customer Success Manager of WinDriver. On the screen, you can see my email. If you have any question after the request, after the webinar, feel free to email me. And if you have a question during the webinar, you can send it on chat. If I don't have the answer right now, then we can take it over the email offline. So let's start. This webinar, in this webinar, we will talk about DMA, direct memory access, theory and practice. We will see a live demonstration of a recorded demonstration, but a full sequence, a full flow of DMA based on our XDMA sample. Now, this webinar sums up a series of 4 webinars. We have 3 webinars on YouTube. The first one is the latest version main features, including predefined actions, which is a great new feature, a huge step towards no-code driver development, and the test certificate INF, self-signed certificate for unsigned INFs on Windows. So we have a dedicated webinar for these features. I really recommend, if you just upgraded or you're not familiar with these features, to watch this webinar and read the documentation. You can find it very useful. The second one was I had a high demand, the PCI DIAG with emphasis on interrupt handler. So basically in this webinar, we dive deep into the PCI DIAG utility and specifically the interrupt handler, the sequence, and how can you utilize this great tool. And the last webinar, it was 2 weeks ago exactly, the debugging webinar. You may already saw this webinar because this is the second time we are doing it. But if you haven't seen it, I really recommend go and watch the video. We basically share our long experience of debugging drivers, whether the methodology, the tools, Windows, Linux, everything. So if you're interested in debugging drivers or you have difficulties with it, I really recommend watching it. Another, let's say, enhancement or a new feature we now have on our website is the WinDriver Academy. It's a series of short videos. We keep adding them weekly, not longer than 3 minutes or 2 minutes, really short videos that demonstrate particular features and usabilities. We keep adding these. So WinDriver Academy, remember it, or WinDriver Quick. We will see such video today. 2 more things. The first one is the predefined action live demo from Embedded World, the exhibition that took place this April. So one of our account managers, Shlomi, demonstrated a great demo for how to utilize the PDA, the new feature. So we have a video. It's something like 9 minutes, and it's very insightful, where you can see how it turns on and off LEDs on the PCI cards, like physical lights, using the PDA on the wizard. And another great content we have now is the blog posts. So we keep adding blog posts to the website. Some of them are more technical, some of them less technical. But now we'll get to the agenda soon, but here we will talk about the research we published this week, comparing different DMAs, types, and methods. So it's really interesting. If you perform DMAs and you want to improve the speed or functionality, then stay tuned. We will go over it soon. So what's on the agenda for today? We will have a really quick WinDriver overview, not too deep, because this is not an introduction. We have an introduction webinar for WinDriver. We will see the DMA comparison and research after reviewing the components of the DMA, and then the research will make sense. We will then see how to implement DMA using the XDMA sample. We will overview it, and we'll talk about the scatter gather and the contiguous DMA. What's the difference between scatter gather and contiguous, and how can you utilize both of them? Then we will see a demonstration of a DMA, a live video, and we also talk about WinDriver samples that we offer in the sample folder and on the wizard. So let's have a quick overview of WinDriver. So basically, WinDriver is a driver development toolkit. It allows developers to develop drivers from the user mode using an API to the kernel mode, which makes the development and debugging much easier. And when talking about things like DMA, it can really improve the development process and experience and save time. And we will see shortly how. So just before we dive in, I want to talk about API types. We have high-level APIs and low-level APIs. High-level APIs are being called from the user mode, and low-level APIs belongs to the kernel mode. We recommend working with high-level APIs only. You can recognize them by the WDC, WDC or WDU, and DMA. Sorry for missing that part. The low-level API does not have the WDC, it's the WD, it's a do, but high-level APIs have the WDC or WDU or WDS initial. Okay, so these are the functions names: WDC, high-level PCI functions, WDU, high-level USB functions, and WDS for server. And for any other name, the function is a low-level API function. And we recommend utilizing the high-level APIs for your conveniency and ease of use. Your convenience, sorry. So what do we offer in terms of DMA? What WinDriver offers? When you generate a code, you can choose the language. If you already experienced WinDriver, you can choose the language, you can choose the development environment, but you can also choose the device-specific customization. And we offer 3 different samples, XDMA, QDMA, for Altera, Xilinx, and Stratix and Cyclone from Altera. These were built for specific devices. Okay, these were built for specific devices. It's not a plug and play driver. You would need to modify these files, this code. However, it contains, and I will show you shortly, a lot of let's say aid or assistance in programming DMA for this device, these manufacturers. So it comes with the library functions for accessing each element of your driver resources. Here we can see a list of access registers, okay, channel registers, host to card, card to host. This is from your project lib header file, customized code. So you can see that we pretty much did some of the work for you. You can simply call the offset, and this corresponds with the device access registry page from the device specification manual. So we have this one. It's a diagnostic program in console mode for diagnosing your device. What does that mean? That means that it's a working code. It's a working code, and if you run it, you can use it as a diagnostic tool, and build on top of that, implement your code on the generated code. And it's a project or solution makefile that you can use automatically to load all of the project information and file into your development environment. Okay, so also the compilation, the building is very easy utilizing WinDriver. So DMA development is hard as is. WinDriver makes it much easier for you. Okay, so now let's talk about the samples. This is a code generated from the wizard. We also have samples, okay, on the samples folder. We have XDMA, QDMA, and Avalon memory mapped. So the Xilinx XDMA sample we will utilize today is a sample mode, is a user mode sample code of a diagnostic utility that demonstrates several features of Xilinx PCI Express card programmed with Xilinx DMA IP. So if you have a Xilinx PCI card and you have Xilinx PCI card and you have the DMA IP, okay, by Xilinx, these samples was written for this IP, for the DMA IP. It's the same for QDMA, okay? So you have the QDMA sample, QDMA IP sample from Xilinx. And we have the Intel Altera PCI Express card, Avalon memory mapped IP. So for each of these, we have a sample. Again, it's not plug and play, or one should not expect it to be plug and play, but after being modified and customized for your specific device and IP, you can get the DMA done fairly quick. And this is how it looks like. By the end of the webinar, we will see how we can perform DMA in less than 2 minutes, okay? In a WinDriver quick video, a live demonstration of how to do it, but basically this is the diagnostic tool. Okay, you can choose the DMA direction, you can choose the completion method, interrupter pooling, we will talk about it quite soon. Enter the transfer buffer, the duration, and then you simply start the DMA. And all the functions are already inside, and you can edit them and modify them and implement your code to these samples. So if you're not familiar with it, I really recommend diving in here. So let's go over the definitions and research results. So when we talk about DMA, what are we talking about? So DMA is a mechanism where data is transferred between devices, okay, without involving the CPU directly. It can be either card to host or host to card. This is the most general definition I could find. So what are the components we're talking about? We have the DMA controller, okay? Your device should have a DMA controller. The hardware component that operates independently of the CPU, acting as dedicated channel for data transfer between I/O devices and system memory. Okay, so we have the I/O device and we have the system memory, and the DMA controller is there to manage the operation. The DMA controllers assumes control of the system bus, transferring data blocks directly without CPU intervention. This offloads memory access tasks from the CPU, improving overall system performance. So why do we need the CPU for? In case we want to raise interrupts. And this is also another functionality we offer with our API to have an interrupt enabled or interrupt handler inside the DMA code, and we will discuss it. We will see shortly how it is done. Another component, and this is interesting, is the IOMMU. It's the Input-Output Memory Management Unit. So this component acts as a bridge between the DMA controller and the system memory. It functions similarly to a memory management unit used for CPU memory access. It translates virtual addresses used by the DMA device into physical memory addresses, and advanced IOMMU implementations provide security features like address space partitioning, and device isolation. Okay, so this component is not a DMA controller. It stands between the DMA controller and the system memory. And we found something interesting because IOMMU is something that you can enable in some BIOSes, and then the operating system manages the DMA through the IOMMU. Now, you may think intuitively that it shouldn't change the speed or should not enhance it because the DMA controller should do that best. However, we found that enabling the IOMMU can end with higher or faster DMA performance. I will show it in a few moments. So in essence, the DMA facilitates rapid data transfer while IOMMU ensures secure and controlled access to memory during DMA operations. They work in tandem to optimize system performance and maintain data integrity. Okay, so this is the component. This is the physical hardware that we need in order to talk about DMA, on a really basic level, 101. Let's talk about the communication method, okay? How we transfer data from the device to the card and vice versa. So the first and maybe the least advanced or sophisticated method is the blocking. Blocking data transfers halt the execution of a program until the transfer is complete. So there is a transfer, and the blocking, as the name suggests, block the program until the transfer is complete. While non-blocking transfers allow the program to continue executing concurrently without the data transfer operation. Okay, so if you don't want to utilize DMA and you want to transfer data using blocking or non-blocking, you can do so with these functions. Remember, high-level functions, WDC read other block or WDC read other. Can go to our documentation and see how to implement these functions. And now let's talk about DMA. So we have two types of DMA we're talking about here. The first one is DMA with interrupts method, and the second one is DMA with polling method. What is the difference between them? So the interrupt performing DMA involves the DMA controller signaling the CPU through an interrupt request, IRQ, where a data transfer is completed, allowing the CPU to continue its execution without actively pulling the status. This method reduces CPU overhead and allows for more efficient handling of data transfers in system employing DMA. So in this type of DMA, there is a transfer taking place. Once it ends, it raises an interrupt to the CPU instead of the CPU continuously asking for the status. So what is polling? Polling involves repeatedly checking a status flag of register to determine if a DMA transfer has completed. This method requires constant monitoring by the CPU, which can introduce overhead and inefficiency in handling data transfers. So we have these two types of DMA, and we have a dedicated ABI for both of them, but now we should ask which is better or which is faster. So the answer is, it depends. It depends on your needs. It depends on your devices, on your setup. It really depends. So you can either check and try to implement both of them and see what works best for you. But there is no one answer to it. Let's talk about DMA types, okay? Oh, what I want to emphasize here is that the XDMA sample supports both, okay? Both DMA methods. Let's talk about DMA types. We have basically two types of DMAs. Contiguous, okay? These are pages, a signal segment of memory, locking it to execute the transfer. While it is easier to program and manage on the device side, it might not be available if contiguous memory of sufficient size is fragmented. So contiguous is allocating one segment of memory. It's not even page because page is a fixed size. Page, segment of memory, one segment of memory, and perform as a buffer and perform the DMA on top of it. what can go wrong? We may not have enough space or enough memory to lock for the buffer to execute the DMA. So it might be easier to manage because you have only one page or one segment. However, it's not robust. And we will talk later about how can we make sure that we have enough memory or at least try. So the second type of DMA is a scatter-gather or SG, which means allocating multiple non-contiguous blocks of memory. So if we don't want to be dependent on specific buffer segment, memory section for our buffer, then we can utilize and implement scatter-gather DMA. And this way, the buffer will be scattered across different pages, and it is more robust. However, more difficult to implement because then you need to start managing these pages. Which is better, which is faster? That depends. That depends again on your device, on your buffer size. If you want to test your device, you can perform a research and see what works best for your device. So after we talked about the framework, about the components, about the DMA types and the DMA methods, let's talk about the research. Now, we had research done on our R&D. You can see, sorry, it is published on our website, WinDriver Media Blogs, comparing DMA performance across DMA methods and types. So we took this hardware, okay, it's a Bitware upscale plus card running an XDMA IP on an x64 machine and ARM machine. We have ARM, and we are not focused on specifically comparing them, but we wanted to test also the ARM machine on Ubuntu operating system and different kernels. Okay, so this is also interesting to see how the kernel version affects the performance of the DMA. So what we've done is we used the XDMA sample of WinDriver, the XDMA DAG, and sent buffers of increasing size to and from the device, host to card and card to host. Okay, so we performed DMA and allocated increasing size of buffer. And I'll show you the graphs soon. We measured the amount of information transferred in 10 seconds. Okay, so the whole DMA took 10 seconds. We tested both interrupt methods and the two types. Now to the interesting part, the conclusion. So the IOMMU DMA method is consistently faster than the direct DMA method, okay? And this is surprising. Now, I'm not saying this will be the same on your device and hardware. However, it is worth trying, okay? And again, if we will go to the introduction, we will see that we want to inspire your own investigations into optimizing transfer speed. So this is not, it's not something obsolete, okay? But it works trying and testing on your systems. Another thing we found out is that the kernel version matters. Newer kernel versions increase the transfer rate and DMA differences between methods. Now, I know that we don't like to upgrade, especially not kernel versions, because things can break. However, newer kernel versions are significantly faster. And this is also interesting to see. Another interesting insight is that larger buffer does not mean faster DMA. Okay, in most cases, there is a point of diminishing performance, meaning that at some point, the buffer size grows, but the performance gets decreased. Or we get a plateau in the transfer rate. So the buffer size doesn't matter at some point because the transfer rate is the same. if you want to talk about ARM, so the ARM machine lagged behind the competition with small buffers, but caught up later. Now, I won't go over all the graphs. I just want to show you an example. So this is the buffer size, and you see the transfer rate, okay, in megabytes per second. Here we compared the IOMMU versus direct DMA. Remember when we talked about the components? So we have the IOMMU and the direct DMA. We can see that they are pretty close in terms of performance when it gets to the diminishing performance peak around, at 1 megabyte. And in 415, it's not that significant, the difference between the direct and the IOMMU and the ARM. However, on newer kernel versions, we can see that it really makes a difference. So in kernel version 6, you will get a significantly faster IOMMU DMA performance with 1 megabyte buffer rather than direct DMA. And again, it's something to change in BIOS. That's it. It's not something you address on your code. So it's worth trying. Go to the website, watch this, read this article, go over it. It's interesting, it's inspiring. It may not say something on your device, but it will raise questions on how to implement DMA and the whole development process. Okay, so let's talk about implementing DMA. In general, this is the flow, this is the sequence. So what we offer, what we are doing as WinDriver in order to enable you to perform DMA with ease. So the flow is pretty simple. We allocate the user mode buffer, and this is, I'm talking about scatter gather, because in contiguous, there is an option to pre-allocate. We will talk about it after reviewing the XDMA sample code, which we are doing right now. So the first thing to do is to allocate the user mode buffer, okay? We need to allocate the memory, and you can see that it can be done using the XDMA sample or your XDMA code. You can choose to lock, and then we get from the operating system the addresses of the locked memory sections, of the allocated memory sections. The second part is to lock the physical memory, okay? This is the user mode buffer, and then get the physical memory locked. We can see that this is a scatter gather DMA type because we have multiple pages. SG buff lock. So we lock the pages. Then you have your own program. We will see it shortly. The part where you need to program your code according to your device. This happens after locking the physical memory. Then we initiate the transfer, and we can see also the data that was transferred during the DMA, and notify when complete, clearing everything, clearing cache, clearing the buffer, disabling the interrupt, and so on. Let's start with the first part, okay? So we have the DMA routine function. Okay, this function performs the DMA transfer. The DMA routine makes several parameters. Okay, we have the handle of the device. This is being called a lot of times during the DMA, calling to the handle. You can set the size of the DMA buffer and specify the addresses, okay, the local addresses of the transfer data. We have a flag indicating whether to use pooling or completion detection, okay? And a flag to indicate the direction of the DMA transfer, device to host or host to device. Another operation that takes place here is the declaration of a pointer pbuff, of type void, which will be used to store a dynamically allocated buffer for DMA transfer. So dynamic buffer means that it is being allocated with every operation. So it's not a fixed memory section, it is a dynamic. On a WD DMA, sorry. Okay. In this section, we lock the DMA buffer and program the DMA controller. Okay, this function opens the DMA channel with the specific parameters. If opening fails, it jumps the exit level. And if we are not pulling, okay, we enable the interrupt. We enable the DMA interrupt, and if we enable interrupt fails, we jump to the exit level. So when we're allocating the buffer, a few things are set here. These are snippets from the documentation. You can go to the relevant section on the documentation and see it there. But when we're allocating the user mode buffer, these are the operations that are taking place. Pre-allocating user mode buffer, locking the DMA buffer, and enables the DMA interrupt if we're not on a pooling method. Okay, so we have the my DMA interrupt enable. Function that when WinDriver returns both user mode and kernel mode mapping of the card's physical memory regions. Okay, the second part is the locking physical memory. Okay, so after we allocated the buffer, we need to lock it to actually lock it. Okay, so again, we have a call for the device handle. We have a pointer to the DMA buffer. Again, talking about we have the local addresses reference, but what is interesting here is the WD DMA. Sorry. Okay, so we have the WD DMA structure, which will be used to store the DMA information. Okay, the WDMA is where the DMA information will be stored. This is the function. Then we have the WDC DMA scatter-gather buff lock, okay, the actual lock that locks the pre-allocated user mode memory buffer for DMA and returns the corresponding physical mapping of the DMA pages. So after it locks the memory, it returns the mapping of the locks DMA message. And on Windows, the function also returns the kernel mode mapping of the buffer. Okay. Okay, sorry, this is what I was looking for. When we talk about the WDDMA, this is from our documentation. You can see the structs of this function. I recommend going over it and learn about it. And now we got to the part where you should add. What do we see here? So my DMA program is a program that device DMA registers. Refer to the device datasheet for details. This is the access register page from our device specification. Okay, we have a device from Xilinx, and we have the manual, and in the manual we have the access registers page. Now, as you saw, in some for some devices, this is already implemented on XDMA sample. However, you need to know your device. You need to know which offsets to access, what to read, from where, at what length, in order to utilize the DMA to work smoothly. So when we're talking about programming the DMA transfer, it is important to know WinDriver and its capabilities and the APIs. However, it is even more important to know your device and know what access registers you can utilize and how to do it. Okay, so we have a descriptor field of the device with the description. This is the part of, and we'll talk about some of what you should do. We have the sample, okay, but what should you implement? So my DMA program is something that the developer should implement in order to the sample to work. So again, my DMA program, sorry. Programs the device DMA registers to the physical DMA page. Okay, so the things that should be implemented into the sample code is my DMA start, which writes to the device to initiate the DMA transfer. My DMA to wait for completion, okay, that's poll the device for the completion or wait for the DMA done interrupt. My DMA interrupt enable or disable is only if you utilize interrupt handler, again here. So after allocating the memory, locking it, and writing the program, we have the transfer initiated. The last part is for closing the DMA, okay? The system resources associated with the DMA are properly released and cleaned up. It includes disabling any further DMA interrupts if they were used and unlocking the memory buffers that was allocated for the DMA operation, thus preventing memory leaks and ensuring the system remains stable and efficient. The DMA close function is responsible for cleaning up and releasing resources associated with the previously locked scatter-gather DMA buffers. And this is the function, okay? Again, calling for the handle, the WDDMA, which includes the pages. Okay, and we have pulling a flag that tells us the type of interrupt used. Sorry, the method used, if it's pulling or interrupt. And as you can see, we disable the DMA interrupts and unlocking and free DMA buffer. So this was the sample, an overview of the XDMA sample. Now let's talk about scatter-gather and contiguous DMA. We talked about scatter-gather, which means scattered memory segments allocated and locked and utilized for the DMA. Okay, so we have multiple memory segments, and here we have a single memory segment locked. In contiguous method, we have only one page, and we need to make sure that the page is free, is available, that we have enough space in our memory to allocate and lock in order to perform the DMA. So on Windows, and currently only on Windows, you can pre-allocate memory, which means that we allocate the memory from the boot. Okay, before the operating system starts and all the programs are running, and they may occupy the place that we want the DMA to be, the memory that we want the DMA to utilize. We can pre-allocate memory on Windows using the INFs. I will show you shortly. And this feature, this option is not available first on Linux, because Linux is much lighter than Windows, and it's not available on scatter-gather because it makes no sense. Essentially, the whole thing of scatter-gather is that it is robust, okay? Even if there is no one large chunk of memory available, you can utilize scatter-gather to perform the DMA. However, on contiguous, if you don't have this chunk of space, it will not work, and thus it's less robust. Scatter-gather is harder to implement because we are dealing with a lot of pages, and contiguous is easier to implement because we have one page. But again, it's less robust. So how can we pre-allocate a buffer on Windows? When we open the device, we have basically two options: the GUI-friendly way, the way WinDriver likes to offer the solution, generating on the driver wizard. You can generate an INF file and define in the INF to pre-allocate the device to host DMA buffers and the host to device DMA buffers. And then this memory will be reserved for your DMA. If you don't want to utilize the wizard, or you can't for some reason, you can manually edit the INF. This is also elaborated on our documentation, and specify the DMA to device bytes, the options, the device to host DMA buffer, etc. So you can do it manually, and you can do it via the wizard. Now, we have the DMA config buff lock. We just said that you can pre-allocate. If you use this flag, DMA get pre-allocated buffer only, that's on Windows. You can use only the buffer that was pre-allocated before. Okay, so if you don't want to take too much memory and to allocate and lock memory in order not to take the resources for other programs, or you may not have enough memory, and you want to make sure that the DMA is utilizing only the pre-allocated memory, you can use this flag, okay, this bit mask, and this way it will, the DMA will be performed only on the pre-allocated memory buffers that were allocated during the boot. If we're talking about Windows, while we're at it, there is another feature that is important to know if you want to perform DMA on Windows, and this feature is kernel DMA protection. If you will try to perform DMA with this security feature on or enabled, your computer will crash. Okay, you will get BSOD. We got it from several clients along the years. This is a protective measure. So if you want to perform DMA on Windows, make sure to disable or turn off the kernel DMA protection. This is also done via the BIOS to prevent crashes and misunderstandings. Now let's see the demonstration of the live DMA. Sorry. I don't know if you can hear this. Okay, I'll take that you cannot hear it, so let's go over it together. Okay, this is where we open the WD debug. This is on Linux, okay? So we've opened the XDMA diag. Okay, this is what we see here. We opened it. This is the sample from the samples folder, yeah? It's an untouched code, but that is working with our device. We chose our device, okay? We chose option 2 and opened our device. And here we have the device detail. Then we choose option number 6 to perform direct memory access. Okay, we want to perform DMA transfer, option number 1, and open DMA. And decide on the DMA completion method, which is interrupts on our case. So when the DMA will be finished, will be done, we will see an interrupt raised. And the interrupt handler is built in the DMA sample. We chose to perform the DMA to device and not from device. And here we can enter, first of all, the DMA channel, the data pattern, okay, and the number of packets to transfer. Then we choose the offset. Remember when we talked about the specifications, we choose the offset for transfer, and that's it, okay? The message signal interrupt number 1 received. We got the DMA status, and the interrupt type. Okay, in this type it's MSI. The DMA transfer completed successfully. This is all it took, 45 minutes, something like that. Seconds, sorry, 45 seconds from the sample. Now let's see the data that was transferred. So now we need to close the DMA. Okay, so when we close the DMA, we see that the interrupt was disabled, and we closed the DMA handle. Again, automatically, this is what the sample does. We just saw the code. You don't need to modify that. Now we need to create another DMA. Sorry, this time from the device, because we want to read the transfer. So we selected the DMA channel, enter the number of packets and the offset. And here we can see the data that was transferred during the DMA. Okay. And that's it, okay? We close the DMA, and we close the DMA. And again, it ended up with the disabled interrupts and cleared everything. Another thing I added to this video, and I think it is interesting, is the debugger. Okay, at the beginning of the video, we opened the WD debug utility, and here we can see all the prints of the debugger. What is it good for? It monitors your program, and you can see what's going on on the backstage. If things are not working properly, you can see what happens. You can save these logs and then compare them to other tests you perform, and see what affected your performance. If it's the buffer size, if it's the method, and so on. So I recommend working with the WD debug. You can see anything but the transfer itself. Okay, it's not logging the transfer, but it's logging everything before and after. So again, the WD debug is a great tool that we also offer with WinDriver. And let's see what else. That's it. Thank you. Thanks for everyone for joining. You can send me questions here, or you can send me questions to my email. I can see already I have one question. Let's see. Okay, so the question Vasily asking is about maximal performance. How the size of buffers in memory affects performance, and does the type of interrupt affect the speed? So as I said, it can, okay? And it really depends on your device and your settings. From a test we conducted, I'll go again to the website. You can see here that different, where is it? We have another article about interrupt and pooling mechanism. And here we have another graph, okay, showing that in some cases, and again, this is only for from our research. The polling mechanism, the polling method, was faster in both cases, but it's not absolute. This is something that needs to be tested on your specific device. Okay, David is asking, have you developed sample code to run two asynchronous XDMA channels simultaneously? I can't say, I'm not sure, I think not. We have a XDMA sample for specific devices. However, if you create handles, for example, the interrupt, you can manage it. This is what I'm saying. You can manage it. We generally don't recommend to try accessing the device with two different programs because it can create a lot of issues. I will keep that answer and have our R&D reviewing it, and I will get back to you. Right now, I believe the answer is no. We don't have something we developed, and it can be done using a shared buffer or shared handler. There are a lot of mechanisms that needs to be implemented in order to allow that, locking mechanism, etc. So we don't have something built in for that purpose. Are there other questions? Okay, so thank you very much, everyone who attended. Feel free to, this will be uploaded to YouTube and our website. Feel free to send me questions or feedback, and have a great rest of your day.